Welcome to another day on the Journey Shake Chem. Now these problems are challenging, so you might want to take out a periodic chart and your penguin sheet and your notes to try to do these to the best of your ability, and we'll go over them in a moment. In number 1A, we have to identify what type of a compound that we have here. And we have a metal with oxygen, and that would be a base anhydride. Whenever we have a base anhydride plus water, what we get is a base. Now, what is a base? A base is a metal with hydroxide, and the metal is barium with hydroxide, and barium is +2. Hydroxide is -1, and therefore I need 2 hydroxides. And at this point, we don't need to balance these equations. That'll come later. That's all I have to do. It's a synthesis. In B, I have an acid anhydride. Now, acid anhydrides, remember, I freak out sometimes when I see those acid anhydrides because I have to find the charge of the nonmetal. So iodine is what I have to determine. Oxygen is -2. There are 3 of them. That gives me a -6. Compounds are always 0. There are 2 iodines. In this case, iodine is +3. An acid anhydride plus water gives me an acid. Well, all acids start with hydrogen. And I know that my iodine must have a charge of +3. There are some different possibilities that we have here. We could have periodate, iodate, iodite, or hypoiodite. It has to be one of those. Now I have to find the one that has a charge of +3, which is what I'm looking for. In this case, oxygen is -2. There are 4 of them. That gives me a -8 on the oxygen. Polyatomic ion has an overall charge of -1. And therefore, in this case, iodine is +7. That's not the one I need. I'll just move on. Oxygen is -2. There are 3 of them. That gives me a -6. The overall charge of this polyatomic ion is -1. And therefore, in this case, iodine is +5. That's not the one I need either. I'll just keep going. In this case, oxygen is -2. There are 2 of them. That gives me a -4. And the overall charge of this polyatomic ion must be -1. Therefore, this one, all right, I get the reward. It's +3. This is the one I'm looking for. But I've come this far, I might as well do the next one as well so that you can see what its charge is. Oxygen is -1. The whole polyatomic ion has a -1 charge. And in this case, iodine is +1. And you can see there is a pattern here, but you also need to be able to figure it out which one it would be. And we determined that it was iodite. And therefore, my acid is HiO2. And I could have said hydrogen is +1 and the iodine is +3, and together that is +4, so I would need 2 oxygens. You can do that in many cases, but if there's 2 hydrogens, like in sulfuric or phosphoric has 3 hydrogens, it may not work as easily. Now in C, I have combined the base anhydride I had in A and the acid anhydride I have in B in order to determine what I'm going to get if I add those 2 things together. And whenever I have a base anhydride plus an acid anhydride, I will get a salt. And again, it is important to know the charge. Whenever I have an acid anhydride, you remember, I must find the charge of that nonmetal. Therefore, I'm going to get a salt. Well, salt is a metal and a nonmetal, or a metal and a polyatomic ion. In this case, I need a polyatomic ion because of all of these oxygens. Barium is my metal, and iodite is my polyatomic ion, and I need 2 of them because barium is +2. Barium is +2, iodite is -1, and therefore I need 2 iodites to get my compound to 0. It is very, very critical that you understand that, because everything that we're going to be doing in the future, we always have to get a formula to equal 0. Now, I also needed to know if the resulting solution, no, you don't need to know that yet. We'll talk about that later. So that's happy news, isn't it? Okay, now I have a salt plus water. And those do the do-si-do. I know that a salt plus water gives me an acid and a base. That's a neutralization. They're just going to do the do-si-do. And when I do the do-si-do, I get iron hydroxide. I get a base. And I get an acid of HNO2. An acid and a base. A salt plus water gives me an acid and a base. And that's how you do number 1. In number 2, we need to determine if these compounds are weak, strong, or non-electrolytes. We know that acids, bases, and salts are electrolytes. So if it's not one of those 3, it's a non-electrolyte. In the first case, we have perchloric acid. It begins with hydrogen, and it is one of my 7 strong acids. You must know those 7 strong acids. If it's a strong acid, it's a strong electrolyte. In B, we have sulfuric acid, and that is another one of my 7 strong acids. It is a strong electrolyte and a strong acid. Oh my, this wasn't a 4, was it? It was a 3. My mistake. So, this is not one of my 7 strong acids. Therefore, it is a weak electrolyte. And the first one was a strong. P2O5 is an acid anhydride. And acid anhydrides and base anhydrides are non-electrolytes. Anhydrides are non-electrolytes. Oxygen is one of my diatomic molecules. It's just oxygen. It's not an acid. It's not a base. It's not a salt. Therefore, it is a non-electrolyte. Now, beryllium hydroxide is a base. However, beryllium is my exception. It's group 1A and 2A with hydroxide, except for beryllium are the strong bases. Therefore, this is a weak base and a weak electrolyte. Now, this one looks like a base. Yes, it does, but it's not. If we understand the definition of a base is a metal with hydroxide. Carbon is not a metal. Therefore, this is not a base. It's actually methanol. It's an alcohol. It is a non-electrolyte. Now, lithium oxide is a base anhydride, and anhydrides are not electrolytes. We categorize them as non-electrolytes. Now, water is also a non-electrolyte. You remember when we had the demonstration? Water does not light up that light bulb, and therefore it is a non-electrolyte. HF, hydrofluoric acid, is not one of my 7 strong acids. It's in the column with a lot of them, but it is not, and therefore it is a weak electrolyte. Or a weak acid. And those are the answers to number 2. Now, there are a couple things that I need to tell you today. And one is that ammonia, NH3, is ammonia. And ammonia is a weak base. Now, I'm not going to explain that to you why it's a weak base today, but we just need to understand that it is a weak base. And we'll learn later on why it functions, why it behaves as a weak base. So for right now, you just need to understand that ammonia is a weak base. And ammonium is one of our polyatomic ions. It is a polyatomic ion, and oftentimes, because it has a positive 1 charge, it takes the place of a metal. So it can be part of a salt. If you have ammonium chloride, it is a positive ammonium that takes the place of the metal and the non-metal, and therefore it is a salt. And it could also be a base if you have the ammonium with the hydroxide. Then it is also a weak base. And you need to be aware of that. So add that to your penguin sheet, and it will come back to help you out. The other thing is that you have a lab tomorrow, and the lab that you will have tomorrow will be a variety of different salts that you will add a drop of water and will determine the pH. That'll be some fun. I love labs, so that's what you need to prepare for tomorrow, and I can't wait to see you.